Okay, so our next lesson is on sigma notation. Okay, so like I said, I talk slowly, but if you'd like to adjust the playback speed, okay, you can make it faster or you can make it slower. It's up to you. I hope you are not tired hearing my voice. Okay, but let's just persevere on this. Okay, sigma notation. Like I said, this is the sigma. Okay, the letter S in the Greek alphabet. Okay, so another name in some books you will see that they call it the summation notation. Okay, so we're going to study what's the use of the sigma notation and how to evaluate uh, sigma notation or series written as sigma notation. Okay, so let's start with the sequence. Okay, so say for example you have the sequence. Let's just start, let's say, with 20, 15. Okay, I think you know where I'm going here. So that would be 10. I'm subtracting 5, right? That's my D. 5. Okay, minus 5, minus 5, minus 5. Okay, usually this is what you will see, and then dot, dot, dot. Okay, that is your sequence. Now, for the sake of our studies, let's just continue this. Okay, so the next number will be 0 here. Okay, you will have 0. Then you will have negative 5, negative 10, negative 15, negative 5, no, negative 15, negative 20. Okay, so if this is our series sequence, and then if you want to add, let's say, the first, let's just say the first 6 terms, 1, 2, 3, 4, 5, 6. Okay, if I want you to add the first 6 terms, so you will just say find S sub 6. But this S has a limitation. It has a limitation of use. Okay, remember, S, you can only use it if you're starting from the first term. Okay, S sub 6 means the sum of the first 6 terms. Okay, but what if I want to find the sum? Okay, not starting from the first term. Maybe I want to find the sum of from the third term, okay, third term up to the sixth term. 3, 4, 3, 4, 5, 6. Okay, let's say. Okay, I want to find that. Okay, so I want you to find in this sequence, okay, in this sequence, the sum of the third term until the sixth term. So I cannot use this notation anymore, okay, because this always starts from the very first term. So that is when you will write it in sigma notation, okay, when you do not start from the first term. So you're going to say, so you're going to write your sigma notation, okay, then you will write which term you want to start. Okay, so N, you can use N. Actually, you can use any letter here, okay, but let's just use N, okay, for continuity because we've been using that. So N, you start from the third term and you want to end on the sixth term, let's say. Okay, so from the third up to the sixth, that's how you write it. And 3 here, 6, and then here, okay, you're going to write your explicit rule. Okay, so we have to find the explicit rule of this. Okay, so you know A sub n. So let's solve A sub n here on the side. So again, A sub n, formula again is A sub 1 Okay, I'm not going to 20 plus d. What is our d? Is negative 5, right? We are subtracting, or we are adding negative 5. 5 minus 10, 10 minus 15, 20 minus. Okay, our d is negative 5. Okay, so negative 5 multiplied by n minus 1. Okay, so that would be 20 negative 5n plus 5. So our explicit rule will be 25 minus 5n. And that is what we're going to write here. 25 minus 5n. Okay? So this is the same as this, but this one is telling you in this sequence, add the third term up to the sixth term. Okay, so let's get familiar first with the summation notation. So say for example, this is an example of a summation notation. Okay, so this is in your book, page 303. So as you could see, this is called the index of summation n. Okay, and that is the lower limit of summation, that is the upper limit of summation, and this is what we call the general term, or a sub n, if it is arithmetic. Anyway, we're studying arithmetic now. Okay, so that's how you will write this. This is your first example of the sigma notation. Now, how do we evaluate this? How do we evaluate this? Okay, so to evaluate something like this, all you have to do is to substitute the n. Okay, again, you're given this. Okay, so let's write it again here. So n, summation of from 3 to 6 of, you always put parentheses, always parentheses. Okay, always parentheses. So how do you do this? This is very easy. You just get the first term by substituting this here. So let's just put brackets, 25 minus 5 times 3. Okay, plus you keep on substituting n. Okay, so now after 3, you substitute the next number, 3, 4, then 5, then 6. Okay, so you're going to substitute. Okay, so here you're going to substitute 3, 4, 5, and 6. Okay, so now let's substitute the next. So this will be 25 minus 5 times 4. Okay, supposed to be straight. Okay, plus 25, oh wait, 25 minus 5 times 5, 25 minus 5 times 6. Okay, so 25 minus 5 times 5 plus 25 minus 5 times 6. Okay, so you see, we are substituting the numbers 3, 4, 5, 6 from the lower limit up to 6. Okay, 3, 4, 5, 6. We're substituting that to n. And then you calculate, then you add. Okay, so this will be 25 minus 15 is 10. Okay, you could see that that is also the first term here. 10. Actually, we're going to get 10, 5, 0, and negative 5. Okay, so then here will be 25 minus 20 is 5. 25 minus 25 is 0. Plus 25 minus 30 is negative 5. Okay, so now it's the same, right? We're adding, okay, these terms here. So you might say why, and I can see it here. You will not always see it all the time. This is just an example for you to understand. Okay, so then you just add these terms. 10 plus 5 is 15, plus 0 plus minus 5 will be 10. So that is the value of this summation. So every time you see something like that, all you do is you substitute the numbers here from this up to this, the integers. Okay, so if you want to, okay, let's do this. Try this A. Okay, so I'm just going to try this A. Get your book, okay, page 303. So it says write the terms in the series. Okay, so evaluate this, write the terms in the series, or this example. You can also practice that example A, and then I'm just going to do this. So can you just try to do this one here, evaluate this, and I'll see you on the next video.